states that the statement of this theorem is every square matrix satisfies its own characteristic equation. What is the characteristic equation?
A minus lambda is equal to 0. Into x.
Determinant of a minus lambda is equals to 0. If we take
ప్రయాద్ వెయిటింగ్ రూమ్ లో ఉన్నాడంట సార్.
అవునయ్యా, ఇప్పుడు ప్రయాదు ఆయన్ని అడ్మిట్ కొట్టాను, నాకు అన్ని కనిపిస్తూనే ఉంటాయి. ఓకే, సో now here the process is how we have to do is they'll give us a matrix. A is a 3 by 3 square matrix. When they give a square matrix, students, this is a very, very important concept and very simple concept. Earlier, one student asked, sir, this much of lengthy problem, how can we solve this much of a lengthy problem in the examination hall? It may consume a lot of time. Yes, it will consume a lot of time, but there is an option for that. You may get a problem from the Cayley-Hamilton theorem, which I am discussing now. Okay, sir, మరి Cayley-Hamilton theorem మీద ప్రాబ్లం ఇంపార్టెంట్ అంటున్నారు కదా, సో అది స్కిప్ చేసి ఇది నేర్చుకుంటా అంటే కుదరదు. Priority. Now, what is the possibility of we can get rain or not now? Yes or no? What is the possibility? Is it 100% chances, or 90% chances, or 50% chances, or 20% chances, or 10%, or 0%? What can we say? 20%, because if you see outside, the climate is full, sun is in the too hot now. So 20% or 30%, it depends upon some different areas, but we cannot guess 90% or 100%. But my idea is even if it is 20% set by some of your friend, but unfortunately in the next 5 minutes the total climate may changes and the rain can come, the rain can fall, there may be a chance. So the priority, so we are just saying about only possibility. So whatever I am saying, probably 90% of chances are there for getting a question from Cayley-Hamilton theorem. So if you are not getting a question, means it is only 10% chances are there. So if you take 10 times question paper, in the 10 times question paper, 8 to 9 times question asked on Cayley-Hamilton theorem, there is a priority that I am saying. So సార్ ఇంపార్టెంట్ అని చెప్పారు కదా, సో ఇది ఒకటి చదువుకుందాము, తత్మంది మొత్తం యూనిట్ మొత్తం ఎగరగొట్టేద్దాం అనుకోకండి. ఓకే, everything is important in engineering mathematics. Okay, so A is a square matrix. Okay, what is the characteristic equation? Determinant of A minus lambda I equals to 0. Okay, just I am assuming that. Okay, I am assuming that maybe like this. I am writing like this. B1 lambda cube plus B2 lambda square plus B3 lambda plus B4 equals to 0. What about b1, b2, b3, b4 or some constants? I'm mentioning some constant. Don't assume that b2 coefficient is lambda square coefficient is always negative. Not like that. And constant term is always negative. In that formula, I explained like that. Lambda cube coefficient is positive, lambda square coefficient is negative, lambda coefficient is positive, and the constant coefficient is negative, like this. Okay, so if this is the thing, if this may be the characteristic equation. Now, what is the statement of Cayley-Hamilton theorem? Every square matrix satisfies its own characteristic equation. That means in place of lambda, we have to substitute capital A, matrix capital A. In place of lambda, okay, I'll mention this with, I'll underline this. Actually, we have to write it with the red color. Okay, so replace lambda with A, then what we will get? Tell me the reduced one. B1 into capital A cube plus B2 into capital A square plus B3 into capital A plus, can I write B4? Yes or no? Yes or no? Please answer fast.
Yes, sir.
Yes, sir.
It's constant.
No. I mentioned here B1, B2, B3, B4 are constants, but when it comes, B4 is constant, that means a scalar, but this is vector, this is vector, this is vector. How can we add 3 matrices with a scalar? No. So, because of that reason, and replace lambda with A and multiply constant term with the identity matrix capital I. So B4 into I. B4 into I. B4 is a scalar. Multiplying that scalar with the identity matrix, we are going to get a a matrix. So sum of all these 4 matrices, that means is equals to which matrix we have to get? Null matrix. If this equation will satisfy, if this equation satisfies, then we can say Cayley-Hamilton theorem verified. So what is the Cayley-Hamilton theorem? Every square matrix satisfies its own characteristic equation. Now I am giving you the main important point, students, how we are going to get, how they are going to ask in the problem. Okay, so every square matrix satisfies its own characteristic equation. So the characteristic equation is determinant of A minus lambda equals to 0. Then we'll get a cubic equation in terms of lambdas. Then we are getting a cubic equation in terms of lambdas. In place of lambda, we have to take capital A and multiply the constant term with the identity matrix. Then we are going to get this one. Okay, the sum of all these 4 matrices must be a null matrix. Okay, now how they are going to ask problems are, better take a matrix. Verify Cayley-Hamilton theorem to matrix capital A equals to, they'll give us a 3 by 3 matrix, a square matrix. So what we need to verify? What is the statement of Cayley-Hamilton theorem? Statement of Cayley-Hamilton theorem is it has to satisfy, capital A has to satisfy its own characteristic equation. So, for that, first we need to find the characteristic equation. That means this one. We need to find characteristic equation. After that, we need to, for verification, replace lambda with A and multiply the constant term with the identity matrix. With identity matrix. Then we are going to get the left-hand side part. Now we need to check. Oh, that means this box, pink, green color box, this equation is satisfying or not. That we need to identify. Okay, so for making our problem simpler, I am going to take here the problem which is solved by us earlier for saving the time. Okay, I'm taking here. Okay, this is a matrix. I'll take. So find okay, verify the, what is the problem? Verify Cayley-Hamilton theorem for this matrix. Control C. Okay, so now I'm taking this as a matrix. Where is it? Okay, right. So I'm removing this matrix and I'm taking this as a matrix. Okay, so for this matrix, what we need to find? First, we need to find the characteristic equation. So what is the characteristic equation we got earlier? I'm taking from there only. So I'm taking this is a characteristic equation. Okay, this is a characteristic equation. Lambda cube minus 6 lambda square plus 11 lambda minus 6 is equals to 0. Okay, I'm taking this. So you people need to write completely. That implies I'm writing direct step because of we are having only 4 minutes left. Is the characteristic equation of capital A matrix. Now this, for verification of Cayley-Hamilton theorem, understanding students, or please confirm one student at least, or post it in the chat box. If you are not able to understand, then I'll repeat total problem. So what is the characteristic equation? Determinant of A minus lambda equals to 0. If we find determinant of A minus lambda equals to 0, this is a thing we will get it. Okay, and in this, for verification of Cayley-Hamilton theorem, what we need to do?
Substitute.
Replace lambda with capital A and multiply constant term with I. Very important step. Okay, I'm taking this as equation number 1. So in equation 1, then if we do that, we are going to get A cube minus 6A square plus 11A minus 6I equals to O. We need to verify this. For verification, we need to find A cube, we need to find 6A square, we need to find 11A, we need to find 6I. What is 6I? Okay, that is your choice whether you need to do it separately or first. After finding these 4 matrices, take our equation A cube minus minus a plus a minus 6a square plus 11a plus 6i. We have to take this after finding all these four things. Take these other things. Minus 6 ikkada plus petana, right? Yes. Now all of you open your calculators. All of you open your calculators and feed A matrix in your matrix capital A in your calculators. Capital A matrix in your calculator. Okay. So how to feed? Already explained earlier. So now I am repeating. Go to shift and choose 4. Sorry, not shift, menu. And in menu, 4 is the matrix. Select 4. Then define matrix. Which matrix we are going to define? Mat A. So select 1. It is a 3 by 3 matrix. 3 rows, 3 columns. And sorry, ikkada edo miss ayipindi. Third row miss ayipindi. Okay. So now I am feeding this matrix 1, 0, minus 1, 1, 2, 1, 2, 2, 3. Okay. After feeding this, what we need to do? What we need to do?
AC.
We need to find A cube. AC. Plus AC. Then we need to find A cube. So in your calculation operations, go to options. Which matrix cube we need to find? Mat A whole cube. So press 3, then mat A whole cube you need to use. Whole cube is, where is whole cube? X cube in your calculators? Above x square. It is in which color? Which color?
Yellow.
Yellow color.
Yellow.
Okay, or cream color. So left hand side top first button, shift is there. Shift is also yellow color. So press shift, then x square. If you press shift and x square, then it will be treated as x cube. So it is showing as mat A cube. Yes or no?
Yes, sir.
So
Yes,
write
sir.
this mat A cube here. That means in your problem, you write separately on the top. But here I am writing direct step. Minus 11 and minus 12, minus 13, and next 19, 20,
20.
and 13, and 38, and 38, and 27. Yes or no?
Yes, sir.
Okay. Minus, we need to find 6 into A square. 6 into A square. Okay. So already mat A feed it. Now we need to multiply with 6. So press 6 after pressing AC. So AC, if you press again, it goes to matrix. Students, hardly I'll take 3 to 5 minutes, not more than that. 6 into mat A whole square we require. So put brackets, put brackets, put brackets.
Sir, after AC, what we should do?
After AC, 6 into A square we require. 6 into A square we require. Okay. So for getting 6 into A square, 6 into, start brackets, then press mat A. How to press mat A? Option and 3. And then use whole square button. Then you are going to get, tell me what you are
Yes, sir.
getting.
Minus 6, minus 12.
Minus 6, minus 12,
Minus 24.
4.
30.
Okay. Other than Aditya, anybody else? Inkoka.
30,
30,
36,
36,
24.
24. One more student other than these two members. Third row.
60. 60.
Okay, one student. 60,
60.
60,
54.
54 plus 11 into A. So again, we need to calculate 11A. How to calculate 11A? Again, press AC button. 11 into mat A we need to get. So option and then 3 mat A. 11A. So write the 11A matrix here again. 11, 0,
7,
minus
0,
11,
minus 11,
11, 0, minus 11,
11, 22,
11,
11,
22, 22,
33.
33.
minus 6i. What is I matrix? 1 0 0 0 1 0 0 0 1. Multiply with 6. What we will get it? 6
0, 0.
0 0 0 6 0 0 0 6. Be careful, students. I have taken here this thing. This is equals to. Now tell me here minus 11 minus of minus 6 plus 6. Minus 11 plus 6 is minus 5.
Minus 5.
Minus 5 plus 11 is
16.
6. No, minus 5
6,
plus 11.
6,
6.
6,
Plus 6 minus 6.
0.
So first element is 0. So calculate like that. All the values you will get.
All zeros.
All elements become zeros. 4C4. You want to write on the screen? I'll give chance, no problem. Therefore, a cube minus 6a square plus 11a minus 6i equals to O, which is equals to O. Then what we can say? Hence, null matrix వచ్చిందా అంటే క్యారెక్టరిస్టిక్ ఈక్వేషన్ సాటిస్ఫై అయింది కదా.
Yes, sir.
Yes, sir.
Hence, given matrix capital A satisfied its own characteristic equation. Hence, Cayley-Hamilton theorem verified. What they asked in the problem? Verify Cayley-Hamilton theorem. That's enough. Finished. So in the tomorrow's class, we will discuss a problem on this model. They are providing capital A matrix. They're asking that verify Cayley-Hamilton theorem. And after verification, we need to find A inverse and also A power 4 using Cayley-Hamilton theorem. For that, first we need to find its characteristic equation. For verification of Cayley-Hamilton theorem, we need to find its characteristic equation. Consider characteristic equation of that capital A matrix. Characteristic equation of capital A is, what is that? Determinant of A minus lambda I equals to 0. But as we discussed, this process may be a little bit lengthy. So that, what is the formula we discussed? Lambda cube minus trace of A into lambda square plus sum of minors of diagonal elements of capital A into lambda minus determinant of A determinant of A equals to 0. For finding this, So it's already 11:28 something. We started. Okay. So lambda cube minus trace of
3
A.
lambda square.
Trace of A is 3.
3 lambda square.
So we'll get 3 lambda square. Thank you. Plus sum
Minus
of
3
minus.
lambda.
So, okay. First, I am writing 1 minus 4 is minus 3 plus second
3
diagonal element 1 plus 2 is 3
minus 2
plus
lambda.
for the third diagonal element 1, third row third column
minus
element
3.
1 minus, okay, we'll get minus 3 into lambda minus det A. So here we required A matrix. So feed the matrix in the calculator. How to feed the matrix in the calculator? Please take your calculators, press menu button and go to number 4. It is a matrix operation. Then define matrix A. So number 1, 3 rows, 3 columns. First row elements are 1, 2, minus 1, and second row elements are 2, 1, minus 2, and third row elements are 2, minus 2, and 1. So after that,
But that is minus 12, sir.
yeah, press AC. Then shift, okay, not shift, sorry. Simply go to options, and then go to determinant, number 2 option, determinant of mat A. Again options, then enter 3. It is a mat A. Determinant of mat A is how much? Minus
9.
minus 9. So we'll get here minus 9. So with this, going to write the final castic equation. That implies lambda cube minus 3 lambda square minus 3 lambda plus 9 equals to 0 is characteristic equation of capital A matrix. Now what we have to do? For verification, we have to replace for Cayley-Hamilton theorem verification, replace, taking this as equation number 1, replace lambda with A or lambda by capital A and multiply constant term with capital I. It is nothing but identity matrix. That implies so 1 becomes like this. Okay, in equation 1. So the one we mentioned is only for our convenient purpose. Okay, so now what we are going to get? That implies the important point I am writing in the red color, a cube minus 3a square minus 3a plus how much we'll get? 9? 9i. Taking this as equation number 2. So now what we need to find? For verification, take only LHS part. In the first problem I mentioned as find out a cube, 3a square, 3a, 9i, like that. But now don't do like that. So what you are going to do is here directly take LHS part. Take a cube minus 3a square minus 3a plus 9i and find this value and write one after the other the values. Already you people know that already we feed it mat A in our calculator. So now what we need to find? A cube. So how to find A cube? Option feed mat A, that means press 3, then mat A you will get on the display, then press X power button, then you will get press 3. Okay, sorry, press X. Oh, why it is not showing now?
Syntax error అని వస్తుంది.
అవును, సింటాక్స్ ఎర్రర్
Sir,
వస్తుంది.
అవును సార్.
ఒక పని చేయండి, 3 ప్రెస్ చేయండి. ప్రెస్ చేసిన తర్వాత ఎక్స్ క్యూబ్ బటన్ ఉందా? వేర్ వీ హ్యావ్ ఎక్స్ క్యూబ్, ఎక్స్ అబోవ్ ఎక్స్ స్క్వేర్ వీఆర్ హ్యాంగ్ విత్ like a cream color. So shift X
Sir,
cube.
shifted.
So now you are getting a cube matrix. Write down the a cube matrix. So what is that? 3
24 minus 21.
324 minus 21. And next 6
21, 24.
21 minus 24, not 24. Next 6 minus 6 and 3. These are a cube matrix. Minus, you find out directly 3a square. So press AC again. So press number 3 and again option, press 3 again, mat A whole square. So we are getting here, what is the 3a square? 9, 18. Any of you are getting anything else? Then please let me know. Minus 18, 0, 27, and minus 18, 0, 0, and 9. Getting the same?
Yes, sir.
Yes, sir.
Okay, next. We need to find 3a. For finding 3a, 3 into again a. Already we mentioned mat A is in place of, okay, plus 3. Then we'll get mat A. So what is that? 3, 6 minus 3, then 6, 3 minus 6, 6 minus 6, sorry, this is minus 6, and 3, plus 9i. What is the 9i value? Is it required to calculate in the calculator? No. What is identity matrix? 1 0 0 0 1 0 0 0 1. So multiply it with 9. What we'll get? Simply the diagonal elements becomes as 9. All the remaining elements will be zeros. So check out what is the sum we are getting. Check 1 or 2 values randomly. So I am checking the first row, first column element. So 3 minus 9 is minus 6. Minus 6 minus 3. Minus 9. Minus 9 plus 9 is 0 blindly. So you check like that 1 or 2 values. All the values will become as zeros. Check it out if you want. Check it out if you want. Check it out if you want. That implies therefore a cube minus 3a square minus 3a plus 9i equals to O. Hence, what can we say? Hence, given matrix
Satisfied
Eight on equation.
its own
Matrix.
equation. Given matrix, capital A satisfied its castic equation. Satisfied Cayley-Hamilton theorem. Mention Cayley-Hamilton theorem. Satisfied Cayley-Hamilton theorem. Cayley-Hamilton theorem. Okay, so taking this as equation number 3, Do I can use, but we have to use after completion of verification. So this one I am taking as equation number 3. Now, what we need to find in the problem, what they asked? Find A inverse and also A power 4. So now, which one you want to find? A power 4 or A inverse? Using this Cayley-Hamilton theorem. If one I gives, then the second one easily you can understand. So, for finding A inverse, multiply each and every term of, otherwise multiply equation number 3 on both sides, with capital A inverse as a post factor. You can treat it as post factor or prefactor. It is not going to become a any difference as a post factor. So the thing I am writing it, the red color is important. So now tell me what we are mentioning here. Multiply equation number 3 on both sides with A inverse as a post factor. Okay. So what I am doing is A cube is there. We have to multiply with A inverse. Minus 3 into A square. We have to multiply with A inverse. Minus 3 A into. We have to multiply with A inverse. Plus 9 into I into A inverse equals to 0 into A inverse. So what it's going to become? Anybody can say? Because of the first problem, okay, I am going to discuss one problem. I am writing it in detailed. So I can write A cube as A square into A, and I can apply the associative property A square into A inverse. Minus 3 into A into. Again, one more A into A inverse I am writing as in brackets. Minus 3 into A inverse. Plus 9A inverse equals to null matrix right hand side. That implies I am going to keep only 9A inverse left hand side. Rest all the terms I am going to take to right hand side. What I am going to get? 9 into A inverse is equals to, one is minus A square into I plus 3A into I plus 3I. Then finally, A inverse is equals to, how we can write A inverse equals to 1 by 9 into 3I plus 3A minus A square. Is it clear to everybody what I am writing? Now, that implies A inverse equals to 1 by 9 into 3i. What is the 3i matrix we will get? First matrix I am writing here. 3 0 0 0 3 0 0 0 3 plus 3a. 3 into A matrix. How to do 3 into A matrix? Use your calculator, scientific calculator. So 3 into option mat A is, so we are getting here 3 6.
Sir, screen lagging, I think.
Screen
Lag aitunda.
maybe it is your network problem. All of you are having the same problem?
Sir.
Mm-hmm.
Sir.
Yes.
No.
Sir. No, sir.
No, sir.
Yes, sir.
Few are getting, few are not getting means it's a problem with you people only. So finding a square. How to find a square? So use option mat A number 3 whole square. So x square button. Then we will get 3, 6 minus 6, 0, 9 minus 6, 0, 0 and 3. So close the braces. Now do the simplification. How to do the simplification? Will you do the simplification? Will you use a calculator? One option is you have to do like this 1 by 9 into find that reduced matrix. That is our A inverse. Or simply use calculator mat A whole inverse. Then you can get the answer is something else. But okay, because of the first one problem. So 3 plus 3 minus 3 is 3. 0 plus 6 minus 6 is 0. Next, here also we'll get 3. 0 minus 3 plus 6 is 3. 0 plus 6, so simply 6. Next, 3 plus 3 is 6, 6 minus 3, so sorry, 6 minus 9 is minus 3. Next, 0 minus 6 plus 6 is 0. Next, 0 plus 6 is 6, 6 minus 0 is 6. Third row, second column element, 0 minus 6, simply minus 6. Next, 3 plus 3 is 6, 6 minus 3 is 3. So this is A inverse. You check using your calculators, you can get same A inverse. Now what we need to find? Anybody can give clue for finding A power 4? Anybody can give clue for finding A power 4? What we have to do? This is just for finding A inverse. What we did? We did
Multiply both sides by A.
yes.
A power 4.
Multiply equation number 3, both sides with A. So for finding A power 4, multiply equation 3 on both sides with A. Sorry, on both sides with capital A. You can mention as post factor because each and every term contains only one matrix as post factor. And the remaining element is constant only. So that, so what is our matrix? What is our equation? A cube minus 3a square minus 3a plus 9i antena equals to 0. This one I am multiplying with a as a post factor. Post factor, post factor, post factor, post factor. Just for identification purpose, I use different colors here. So what we'll get from this? A power 4 equals to, sorry, A power 4. Can I take all the remaining terms to right hand side? In the single step, I am doing that. So 3a cube minus 3, sorry, plus 3a square minus 9a. That implies a power 4 equals to, so use your calculators and find out immediately 3 into a cube. So getting that, 972 minus 63 and second row elements 18 Next 63. Less than 1 minute student going to finish the meeting. Please rejoin with the same link. Minus 72. Next, third element 18 minus 18 and 9 plus 3a square. So 3 into again option number 3 is square. 9 18 minus 18 and second row element 0 27 and minus 18 0 0 and 9. I hope all of you are following with me with your calculators. 9 into options mat A number 3. So 9 18 minus 9. Next 18 9 minus 18 18 minus 18 and 9, and you do the simplification, students, then you'll get a power 4. So if the meeting closes, please rejoin with the same link. Then this is a power 4. And one more point I'll discuss once if you rejoin. So doing the simplification, 9 plus 9 minus 9. So which one is better, students? You use your calculator and find out a power 4. So using your calculator, you are unable to find a power 4. So what you are going to do is mat a whole square into mat a whole square. Use that option. Mat a whole square into again mat a whole square. Something just now we got it. By using Cayley-Hamilton theorem, we got a power 4. How we got a power 4 is a matrix. How we got a power 4? By multiplying equation number 3 on both sides with capital A. Okay, so we got a equation, from that getting a power 4, and finally we are finding a power 4. But now in this problem, what they're asking, express a power 6 in terms of A to the above problem. That means, for example, if they're not asking a power 4 for the previous problem, if they're not asking a power 4 for the previous problem, but they're asking express a power 4 in terms of A, then you write this one and you can stop it here. That's enough. But now what they're asking, we need to find a power 6 in terms of A. For finding a power 6 in terms of A, what I'm going to do is here, this equation we have to take as equation number number 4, I think. What I'm going to do is multiply equation number 4 with a square on both sides. Okay, not a square, I'll take a only. Multiply equation number 4 with a on both sides. On both sides. Then if we do this, then what we will get? A power 5 equals to, actually it is a power 4. A power 5 equals to 3a power 4 plus 3a cube minus 9a square. Yes or no? Check it out. Minus 9a square. Again multiply with a. Taking it as equation number 5. Again multiply with a. So you can do directly with a square, no problem. But why I'm doing this, you can know it. A power 6 is equals to 3a power 5 plus 3a power 4 minus 9a cube. Okay, this is the problem. But sometimes they may give multiple choice like this. This bit, what I am going to explain now, is useful for competitive examinations for GATE and all. they will not provide a power 6 equals to this. Then what they are going to do is this. With this, you can complete your problem in your examinations. But we have to substitute here 3 into what is a power 5? 3a power 4 plus 3a cube minus 9a square plus 3a power 4 minus 9a cube is equals to, how we can write? I am writing direct set. 9a power 4 plus 3a power 4 becomes 12a power 4 plus 3 3s are 9. 9a cube minus 9a cube. So a cube term does not exist. So what is the next one? Minus 9 3s are 18. 18a square. So this is a power 6. Now, what is a power 4 value? 12. What is a power 4? From equation number 4, check it out. 3a cube plus 3a square minus 9a, I think. Yes.
Yes, sir.
Minus 18a square. Then what we will get? 12 3s are 36a cube plus 12 3s are 36a square minus 18a. So we'll get 18a square. 18a square minus 9 12s are 108a. So this is a power 6. So there may be a chance in your objective type questions, that is a multiple choice questions, this is correct or this is also correct. Okay, there may be a chance. Anything they can ask in objective type questions. So I'm going to take it as this is one matrix and these are one group of terms. So you try to use the associative law, then you can write it is as P inverse of AP into P inverse AP is equals to, what is the right hand side? D square. Sorry, I mentioned already D square. No. So D square we will get. Now in the next step, again apply the associative law. What we will get? P inverse of A into P into P inverse AP. Ikkada oka bracket ostadi. Here you will get one more bracket. Again, if you apply the associative property, I am giving in detailed ga step by step rastunna. Actually ga meeru skip chesesi direct step rayachu ikkada. P inverse A into now I am treating this is one group. So what we'll get? P into P inverse into AP applied associative law is equals to D square. Then P inverse A into, what is P into P inverse? I into AP. So if you do all the multiplications, then what is going to get left hand side? P inverse A into A into P is equals to D square. So that implies P inverse A square P equals to D square. So this is important. Now P inverse AP equals to D, then P inverse A square P is equals to D square. Similarly, what can we prove? Similarly, we can prove, we can get, what we can get? P inverse A cube P equals to D cube. Okay. And P inverse A power 4 P is equals to D power 4. But, and so on. What we can get similarly? And so on. What can we get? P inverse A
P
power
inverse
n into A power n into P equals to D power n. This thing can happen. But what we need to find? A power 4 we need to find. For that, I am finding A power n here. So what I am going to do is here, on both sides, pre-multiply with the P and post multiply with P inverse. Why I am writing this step? If we do this, then what we are going to get? So left hand side, with which one we have to multiply? Actually, P inverse A power n into P is there, is equals to D power n is there. Now with which one we have to multiply? Pre-multiply with the with P and post multiply with P inverse. Then what we will get? That implies using associative law again. So P into P inverse is into A power n. P into P inverse is equals to P into D power n into P inverse. So that implies I into A power n into I we will get. So finally, what is the left hand side part we will get? What is the left hand side part we will get? A power n equals to P into D power n into P inverse. For example, if they're asking find A power 4 using diagonalization process, then what we will get here? A power 4 equals to P into D power 4 into P inverse. మీరు అది చేయాల్సిందే. మీరు ఇక్కడ ఏం చేశారు? Diagonalization. Okay, problem on diagonalization I'll take. What we did, ఇక్కడ ఏం చేశాను చెప్పండి? P inverse AP equals to P transpose AP. You have written P inverse and A and also P. But in place of these are the things what you have to write now. You have to write P and D power 4 and P inverse. How to find D power 4? For example, this is D. Then how to find D power 4? How to find D power 4? Simply square the diagonal element. Sorry, simply increase the power of diagonal elements with 4. So 6 power 4, 0, 0, 0, 3 power 4, 0, 0, 0, 2 power 4 is D power 4 value. Then you no need to use again feeding D matrix in the calculator and again finding D power 4 is not required. Okay, is it clear, students, to everybody? All the concepts? I'm going to clear this. If any doubts are there, then you can ask.